Hi everyone, we're students of RV College of Engineering and our project is to develop the next generation of security systems. Well, the problem that's pertaining in the real world right now is security. People want to keep their information safe, people want to keep their valuables safe. Well, we have come up with a solution to tackle this problem. Let's get on to it.
What's so unique about every human being? Our thoughts. If two persons are asked to think about the same entity, different images appear on their mental screens. Our thoughts distinguish us from others. So we thought, why don't we use our brainwaves as password for our security system? Seems interesting. Let's see how it can be implemented. We use active dry electrodes to obtain the EEG signals from the brain, which is then conditioned using instrumentation amplifier and op-amps, which act as filters and amplifiers. We then process the EEG signals using machine learning algorithms, and these processed signals are finally transmitted using a transmitter. At the receiver, the processed EEG signals are received and compared with the already existing or stored EEG pattern with the help of an MSP430. If a match is found, the lock is opened, else the lock is not open. Active electrode headset is mounted on the subject's head, which processes EEG signals and gives consistent values of concentration, attention, and meditation. We are using NeuroSky for this purpose. Puzzlebox Brainstorm is an open source software which is used to capture as well as plot EEG signals. In our project, we are using it to visualize human thought about movement. Thresholds are set based on the levels of concentration and meditation to classify the EEG signal as front, back, left, or right.
We have made 3 PCBs. The power supply PCB is used to generate 3 volt power supply from a 9 volt battery. The INA333 IC is used as instrumentation amplifier to remove 50 Hz power supply noise. Its output is given to the next board containing OPA333 which is used for signal conditioning and filtering. Its output is given to oscilloscope of the analog discovery kit, which can be viewed in the PC. In this way, the EEG signals are obtained for testing purpose.
This snapshot shows the first phase of our project. We are at the verge of obtaining reliable EEG signals from electrode, but to prove the concept of opening lock in limited time, we use NeuroSky. We assure that this would be developed in the course of time.
Manojavitham in action. Ajit will be transmitting patterns forward, backward, right, left using the NeuroSky to the MSP430 over there. We'll be monitoring these signals on Adarsh's laptop using the serial window. To verify the real-time working of the system, me and Karthik will be recording the videos on both sides. Case 1. For simplicity purpose, we've taken the password as forward, right, backward, and Ajit will be transmitting the same sequence to the MSP430 over there. We can monitor the signals received by the MSP430 on the serial window, which is on the bottom right corner of the screen. Since we have sent the right sequence, the lock should open, which in this case, our LED should glow green. In this case, Ajit will be transmitting a wrong sequence to the MSP430 over there. Since he is transmitting a wrong sequence, the red LED of the MSP430 will glow, indicating that the lock should not be opened.
conclude, we have proved the concept of opening the lock using brainwaves. But this is not the end. The future scope of this novel security system is in bank vaults, ATMs, and home security systems.